Hey everybody, today I just want to do a quick video about another type of graph. So what this is going to be is a digital waveform graph. So if we open up our palettes, we have digital waveform graph right here. I already have one set up. As you can see, it looks just a little different than the other graphs, but for the most part pretty much the same. We do get this on the left side kind of plot legend basically for lines. And then there's some built-in logic as we run this, you'll see, that is kind of unique to this. But yeah, let's go take a little look at the code real quick. So I just wanted to show before we start, this digital waveform graph, if you notice, looks a little different on the block diagram. So it is kind of a greenish color, and if you notice, the data type that it accepts is a digital waveform. So if you're interested in messing around with these are similar to traditional waveforms in LabVIEW. So if you go to the waveform section of your palettes, you'll notice at the bottom there's this digital waveform section. And you get similar-ish components, right? So you can get waveform components, get digital components, build digital waveform, and then there's, functions for, appending and, stuff like that. And there's also a pattern generator, which you can basically just specify how many signals, the sample rate, the number of samples, and it'll output your digital waveform for you. So if you just want to hey, generate a square wave with these conditions, this will do it for you. And you can also build them similar to how you build waveforms, where you have a Y and a DT and a start time and stuff like that. So this is where you're going to find all of those. And there are some cool conversion functions as well. So you can convert between different data types to digital waveforms. So this is where you're going to find everything you need to make those. Let's walk through just this simple example here. So what this is going to do is this loop is just going to run over and over and over again. And here, while I talk about this, let's run it. So yeah, you can see we're calculating a number. We're displaying all 16 bits here. You can see which ones are high and which ones are low. And here you can kind of see one of the cool things about digital waveforms is I have my line 0, which is the only channel I'm using. And I can see each individual bit. So from 0 to 1 would be 1 bit. I can see that that's 0. All of these bits here are 0, and I can see which ones are high. And it automatically labels them as a 0 or a 1. So I can use this for, honestly, kind of like a logic analyzer, right? Where I can just have serial bus or various digital waveforms, whether that be a PWM signal or just about anything digital, right? And I can actually break that down here, and then as I add more lines, it's just going to add them below in a different color. So I can have one line, maybe I have a transmit and receive, right? So I would have 2 lines, or I could have a whole bunch, right? If I'm doing some complex kind of logic analyzer type stuff. So yeah, this is kind of our demo where it's just incrementing based off the loop count, and we are basically breaking that number apart and displaying it here so you can see the actual kind of binary of each of those numbers. So let's go take a look at the code again. So as you can see, I'm pulling the iteration count, and here, yeah. So yeah, I'm pulling the iteration count, and then I'm converting it to a 16-bit integer just because I just want to work with 16 bits here. And then I am displaying that on the UI. I have that set to hex, so it's displaying it in hexadecimal, hence why you see the letters in there. So then let's look through the rest of this algorithm. I'm using the number to Boolean array to basically take that number and convert it to the array that you're seeing on the front panel, which is just basically representing each individual bit. And then I am reversing the array. Just that way it gets us the LEDs in the order that that you would typically see if you were like writing this out in binary, right? It would be like 0, 0, 0, 0, 0, 0, 0, and then, your ones, and as it gets bigger and bigger, right, then you start getting the ones further and further along. Otherwise, it's just the exact opposite where, for like example, for 1, right, you would just have this first one. So it just flipping it. Then I'm using this Boolean to 0, 1 function to convert all of those true falses to zeros and ones. I have to build the array just because the digital waveform types want 2D arrays. So I don't necessarily have to have 2 dimensions, but I have to pass in a 2D array. So this just creates a 2D array that really only holds, one array in it. I'm transposing it. And then I'm using that build digital data function that we saw in the palettes to pass in that digital data. So this is, again, just a whole bunch of zeros and ones. And that's all it is zeros and ones. And then I am using the build waveform to actually pass in this digital data. And if I wanted to, I actually could also expand this and set like a DT as well. If, not... Like, for example, right now, everything is 1, right? So each bit represents 1 on the x-axis. If I wanted to change that, I can change that, right? So, if you're looking at bits, 1 makes sense. But if, for example, you were looking at like a digital pulse or something like that, and you want it more on like a time scale, right? That could be like milliseconds or microseconds or something like that. Then you can set that DT accordingly. And then we're just writing that to the graph. So that's really, a simple example of using this. But yeah, that would kind of be some of the cool uniqueness of digital waveform graphs. Like, as I've mentioned in previous videos, your most common LabVIEW graphs are your charts, your graphs, and your XY graphs. So these aren't very common, but they are cool and they're unique and they do have a purpose. It's just not as common of a use case, but they're really cool. And that would be kind of the foundational basics of working with digital waveform graphs in LabVIEW. Thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.